Welcome to Kenton's videos. Enjoy the video.
You start by ensuring compatibility. Confirm the model checkpoint, tokenizer, and license allow fine-tuning. Once done, prepare your dataset with a clear train/validation split and balanced examples. This avoids noisy gradients later. Next, configure hardware and runtime. Choose batch size to fit GPU memory, enable mixed precision if supported, and pick an optimizer and initial learning rate. Make sure your experiment tracking is live, so you can compare runs and rollback if a trial diverges unexpectedly. Once training begins, control complexity by freezing early layers or applying gradual unfreezing so you preserve useful features while adapting to your task. Then, schedule learning rate warm-ups and decays and use gradient accumulation to simulate larger batches. This stabilizes updates. Monitor training and validation metrics in real time and log examples of model outputs. Make sure to checkpoint at steady intervals and validate on held-out data so you can resume from a solid state if you need to adjust hyperparameters mid-run. You finish by evaluating across metrics and qualitative checks. Test accuracy, F1, calibration, and review failure cases to ensure no systematic bias. Once satisfied, optimize for deployment, quantize or distill to reduce size, prune unimportant weights, and convert to the target runtime for latency testing. Finally, run real-world tests and monitor drift. If training was unstable or performance degraded, reduce the learning rate by 5 times, increase batch size or rebalance the dataset, and retry from the nearest good check.
Thanks for watching. Consider subscribing if we helped you.